Okay, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, wassalatu wassalamu ala rasulillah. So hopefully my audio and video is clear to you. All right, so if you have problem, please let me know. I've already started the recording session. All right, so in today's class, inshallah, we'll start a new topic for our class. So we have already covered the PLC. As you know, our midterm will cover from PLC to pneumatics, okay, and the combination of those, okay. Pneumatics we start today, inshallah, and we'll try to finish in this week or maybe early next week, okay, so that we can go to the midterm on 17th, on 17th Friday, right? Okay. Have you downloaded the slide yet?
Yes.
Okay. So any one of you have experience using pneumatics before for your projects?
No, sir.
No, no one. So, okay, right there are still people joining the class. All right. Okay, so let's start the slide. So as I told you, we only focus on the learning outcomes of the course. So I will skip the items that is not in our LOs, but of course it's good for your knowledge, for your additional knowledge. All right, so we want to focus and cover the LOs so that we can go through the exam, because we only have 1 month left, right? Okay, so pneumatics, okay. Before this, we put it pneumatics and hydraulics, but the thing is, those two, use the same principle, use the same terminology. All right, so rather we focus only pneumatics, but of course, whatever you learn for pneumatics can be transferred, to the domain of hydraulics. Okay. All right, pneumatics. If you heard about pneumatics, the first thing come into your mind must be something that can be controlled by compressed air. All right. So, let me share my screen. Okay. This one, share. Okay, can you see my screen now?
Yes, sir.
All right. Okay. All right. So this is the slide that you can download in the iTalim. All right. So this is the element that you can see in the pneumatic system. So basically, for the electrical, you have the motor, right? And you have the motor as the actuator, right? To control an output. All right. So for this hydraulic, of course, we use hydraulic, but it's the same for the pneumatics. So hydraulics, the only difference is that hydraulic use liquid. All right. As for the pneumatics, we use compressed air. Right. It is air. Of course, it will be very noisy. If you if you use a pneumatic system, it will be quite noisy because it has to release the compressed air into the atmosphere every time, right? So here you have the reservoir here. So in the case of pneumatics, this one is the compressed air, all right? And then you have the filter, the pump, all right? So you have the regulator, right? And then you have the control valve, all right? Control valve. And then note that we also have this connector, right? Like a pipe here, right? It's the same, if you want to see it as a electrical circuit. So if in the electrical circuit you have the wiring, so for the pneumatics you have the piping, right? Piping system, all right. And then you have the control valve to control the output, where for the pneumatics is always the cylinder, all right, the cylinder to control the cylinder. So using this control valve, you can control the cylinder to go, advanced position or retracted position, right? If you are whether you want to pull or you want to push towards the top, right? Okay, so I will skip lots of things here, but of course the things that you can read by yourself, I just skip. All right, so for the one that needs explanation, I will go through that. Okay, so these are the comparisons between these systems, so electrical, hydraulic, pneumatics. All right, so you can go by yourself. So if you see here, linear actuator is different. Even the energy storage is different. All right, so you go by yourself. All right, so have you seen any hydraulic system before? Can you give me one example? Hydraulic or pneumatics in your everyday life?
Hydraulic in the car.
Lorry brake system, sir.
Lorry brake system using which system?
I think pneumatics because it have a loud noise.
Yeah. So every time you hit the brake pad, it will go like psh, right? It will create the sound of air, right? Okay. Other than that, any more examples that you can think of?
Airplane, sir. Airplane.
Sorry,
Airplane.
airplane. Which part of the airplane that you think use pneumatics?
Mm-hmm. I think the
I
engine
think
maybe.
landing gear, sir.
Landing gear. Landing gear use pneumatics. Why do you need pneumatics? Bus door use pneumatics. Okay, yeah, bus door. All right, even in in the minibus you use the pneumatics, right? All right. All right. Car workshop, the car lever. Yeah. So the car lever use pneumatics or hydraulics? I think we will use hydraulics, right? Hydraulics to to uplift the car. All right. Screw jack. Screw jack. Okay, let's see. Okay. Why some people live in the class? So I think you need to use the IIUM email to join this. I think so, right? Otherwise, you will be automatically kicked from the Google Meet. Okay. All right. So let's go to this one. Okay. This one you go by yourself. Okay. It's not in LOs, but you can read this by yourself. Okay. So, all right. So this one type of pump, this one just type of pump, gear pumps, right? You can see this by yourself, all right? Filters, compressors, right? To compress the air, right? One good thing for the pneumatics is that the energy source, relatively free, all right? You can get the source from the air, from the atmosphere, and then you compress the air as the source for your system, right? It is, you can say, sort of free, right? Very cheap. All right. So this one is the compressor, type of compressor. You have lots of compressors. Okay. This one, from compressor to your system, you have the cooler, because compressed air is very hot. So you have the cooler, and then you have the dryer. Okay. To remove the air mist. All right. Okay, you go by yourself. This one. This one is the theory, the calculation that you have gone through in your first year, Pascal law, right? Reynolds number. Still remember in thermodynamics, Thermodynamics. So we'll skip this. Energy equation. Still remember this equation?
Yes, sir.
What's the name of this equation? I think some of you just took thermofluid last semester, right? Thermofluid is I think 4 credit hours or something. All right. So what is this? What's the name of this equation? Still remember?
Bernoulli equation.
Sorry?
Bernoulli equation.
Bernoulli. All right. Bernoulli. All right. Bernoulli. So, but of course, this is not important for this class. Just want to show you that these are some of the theories that you can find for the fluid system. Okay. Okay. So now we go to the pneumatics system. Okay. So this is the standard for the circuit design of the pneumatics. All right. So at the bottom, so it is drawn from bottom to top. All right. So if in the electrical, you have the power source as the, start with the battery, right? So now we have this system as a source. All right, the compressed air. All right, so this one, and then you have the this one, you call it the safety switch. All right, so this one is this at the bottom is the power source, all right, or the supply elements, right? So this one is not important for the design, but what important is after that, right? So after that, you can see the input elements, right? The switches, right? So for example, this one is switch 1S1, right? 1S2, 1S3, right? So this one is the push button. So this one is I think roller lever as the limit switch, right? So you have the power source, input elements, or the switches, and then you go to the processing elements, or sometimes we call it the logic elements. So here you have the so this one is the OR gate. Okay, 1V1. If you see the S is for the switch, V for the valve. Okay. All right. So maybe in the processing element here, you can find, the timer or the pressure regulator. Okay. So we'll see after this. All right. So, but you need to get, this concept, the design concept first. All right. So you start with the supply element, and then switches, and then processing element, and then go to the control element. Right. So this is what we call DCV. So we'll go more detail on that. DCV is the directional control valve. So it also use V here because it is a valve, right? So if this one is 1V1, so this one is 1V2, all right? Control element, and then it is used to control our power component, all right? Which is a cylinder, all right? A cylinder. So you can see this 1A, A for the actuator, all right? 1A for the actuator. And then you can see also you have the 1S3 here. So this one is the switch here, all right? So we'll go into more detail on that. Okay. Oh, still I have to admit someone. Okay. All right. Okay, so this is the concept, the basic concept of the pneumatics design. So power source, switches, logic or processing elements, and then the control valve, and lastly the cylinder, right, or the actuator. All right. Okay. Yeah. So this is what I said just now. Switches go to processing element. All right. Or in some cases this might be skipped. All right. So maybe directly go to control element and then to control the cylinder. Okay. All right. So this after this you will see some symbols that are very important for your pneumatics study. So this is the power source. All right. So this is one of the most important one. So this one maybe you won't use very often, but this pressure source is very important. So it's the triangle. Okay, triangle. Okay. All right. So this is the the power source. You can find this in any hydraulic system. So if you go to your lab, you should find this one. Okay. So this one is the combination of compressed air filter, regulator, lubricator. So all in one system. Okay. This is the symbol. Okay. Power supply. Okay. And then this one is the ports. Okay. It's the ports. Wait. Okay. So this is very important to understand. Okay. So we call it, you have two elements for this. You have the ports and switching position. All right. Ports and switching positions. All right. What are those? So let's see the first one. So it is called two-way valve. All right. Two-way valve. All right. Normally open position. All right. What is two-way valve? So it is, the first two is the number of ports. All right. So you see here, 1, 2. All right. Only 2 ports. All right. And two-way meaning that it has 2 switching positions. Right. So the first box at your right is the first position, and then you have the second position at the left. All right. So the left also have the same number of ports. So it has 2 ports. So if this one is port 1 and port 2, the left also have the port 1 and port 2. All right. So this is called two-way valve. All right. Let's see the second one. So the second one is three two-way valve. All right. So three two-way valve meaning that you have three ports, 1, 2, 3. Okay, and two positions. All right. The first position at the right and at the left. All right. So at the left also have three ports. All right. The same for for this one. But this one is not normally open. This one is normally closed. All right. Why is normally closed? So you can see here. All right. Port 1 always is the port for the source. All right. Source port. One is for the source port. All right. So if you see here, the source port, so at the right position is the the starting position. All right, the initial position. So when it is in the initial position, if you see the source port is blocked, right? It's closed. So it is normally closed position. Okay. So as for this normally open, you can see that port 1, which is the source port, have the connection directly to the controlling port, which is the number 2. Right. So this number 2 after this will be connected to the to your power element or to your directional control valve. Okay. So normally closed, normally open. So this one might be a little bit confusing if you compare the term to the electrical ones, right? So if you go back to your electrical electronics term, normally close, what is the meaning of normally close? Can someone tell me? Normally close, do you have the flow of electrical there or not? Normally close.
Yes, we have.
So normally close meaning that there is a flow of electric signal, right?
It's connected.
All right. So but for the pneumatics, you can see that it's normally closed, meaning that it is the port that is closed. All right. Not the flow. So you see that normally closed, you don't have the flow. All right. So for the normally open here, meaning that the port is open, so you have the flow of air pressure, right? The compressed air. Okay, so might be a little bit confusing, but if you go, if you go through and really understand the system, then it's not really confusing. Okay, so this is two-way valve, three two-way valve. Okay, three ports, two-way, two positions. And then we go to the next one, four two-way valve. All right. So four ports, two positions. All right. The initial positions. And then this one is, if you press the push button, for example, the position here will be selected. Right. But of course, this one is the initial one. So as you can see here, flow from 1 to 2 and from 4 to 3. All right. So you can see the arrow there. So this one, 1, which is the source, flow to port 2, right? So port 2 here will go to some controlling elements or directly to your cylinder. And then from the cylinder, go to port number 4, right? And then, so 2 and 4 is our controlling ports, okay? 1 for the source, 2 and 4 is for the controlling ports, and then from 4 to 3. All right. So 3 is the exhaust port. All right. So meaning that from 4 to 3. So this way exhaust meaning that it will exhaust the pressured air to the atmosphere. Okay. Right. So that's the concept. So meaning that for the first position, from 1 to 2, And then for the second position, you can see that one flow, the air flow from 1 to 4, right? And then from 2 to 3. Okay, we'll see in our software after this to see more clearly. This why I just want to to show you the basics of the ports, which is very important. Okay, so let's go to the next one. 5 two-way valve flow from 1 to 2 and from 4 to 5. Okay. All right. So here you can see you have the additional port here. All right. So as I said earlier, one for the power source, right? Source ports, 2, 4 for the controlling ports, 5 and 3 are for the exhaust ports, right? So you can either exhaust through 3 or 5. Okay. So here, if you see 1 to 2, all right, 4 to 5, and 3 is blocked. All right, 3 is blocked. So it's in the initial position. So if this position is selected, now you have the flow from 1 to 4. Okay, 1 to 4, and then here 2 to 3. Okay, for the exhaust, and then 5 is blocked. Okay. Okay, and then we also have this not only two-way valve, but we have also the 3 positions valve. So this one is the 5-3-way valve. All right. So mid position closed. So the initial position is at the center, at the mid port or mid positions. All right. So so for in the initial position, you can see that all ports are blocked, right? All ports are blocked. And then if you choose the position at the left, you can see that the flow from 1 to 4 and 2 to 3. Okay. As well as if you choose the right position, it will flow from 4 to 5 and 1 to 2. Okay, 3 positions. Okay, so if you have any question, you can ask directly. You can interrupt me at any time. Okay. All right. So let's see first in our software. So this is the Fluid Sim Festo software. Okay, I just want to show you. So okay. All right. Before that, because this one is cylinder. I haven't talked about cylinder yet. Okay, doesn't matter. We go to our software here. All right. Okay. So this is our port, right? Our directional control valve. All right. So can you tell me what type is this? Anyone?
Two-way.
Two-way. Why two-way?
No. Sorry, sir.
So which one?
3 two-way, sir.
Three-way. Why? Why three-way?
Has 3 port
Okay.
and 2-way
3 ports and 2 positions, right?
position, yeah.
All right. So 3 ports meaning that. So if you can see here, let me. Okay. Get it bigger so that you can see. Okay. So you have the port 1, port 2, and port 3 here. Okay. Okay. Let's delete this. So this is our you can actually, this one you can actually add the push button. Okay, go to property. So here left actuation, so you can put push button and other. So this one is foot pedal, for example. Okay. All right. So this one maybe you can use anyone. Just want to show. All right. So and then you have the spring at the right hand side, right? So this one can also be added. So spring return. Okay. So meaning that in the initial position at the right, all right, where the the spring will take effect, all right, as if you push this push button, this position will be selected. Okay, so this one is 3-2-way valve. All right, so this is our cylinder. So basically you have two type of cylinders. This one is single acting cylinders. Okay, single acting cylinders. So this one is the double acting cylinder. All right, single acting, double acting. So what's the difference? So this is easy. So single acting is you only have one port to control the cylinder, all right, with the spring effect. Okay, this is the single acting. So double acting, what is the difference? So you have the two ports, right? So you can control the advance or the retract position. Okay, that's the only difference between those, right? So single you have one port, double acting you have two ports. All right. Therefore, so for the 3-2-way valve, all right, you can see that you have one port at the top, right, which is port 2, right? So let's connect this. Okay, so meaning that port 2 now is connected to our cylinder. All right, so this one in reality is a pipe, right? Is a piping, right? Let's show you the real one. So if you go to pneumatics, okay. You use this, all right? You use this, okay? So if you have a DIY project, to water your plants, for example, you always use this one, right? Okay, use this one. So in reality, the lines that we have in our software here, all right, is this blue piping. Okay. All right. So now we connect port 2 and our single acting cylinder. All right. And then we have the port 3 for the exhaust. So exhaust here, triangle, heading towards the bottom. All right. Right. If the pressure source cylinder, moving upwards, right, going upwards. All right. So for the source, you connect to this one, because one is the source port. All right, from the source to one in the initial position, one is blocked, so the air from the source cannot go through. Right, and you can see that the air from this pipe to port 2 and then go to port 3, which is eventually go to atmosphere, right? So in initial position, our single acting cylinder, it is in retracted position. Okay, all right, so here go to exhaust, go to atmosphere. All right, what if we choose this one? So now we push this button. All right, so this position will take place. Right, you can see that the air pressure from the source go to port 1, then port 1 to port 2, port 2 to our single acting cylinder, and then it will push this cylinder, right? So push meaning that it is in advanced position. All right, it is in advanced position. So if you release the push button here, all right, if you release, this spring will return this valve into the initial position. So now it will directly retract, okay, go to atmosphere. All right, so let's see the simulation. So this is in initial position. So pressure from source is blocked, so nothing happened. It is in retracted position. Now if we push here, all right, so now you can see the the single acting cylinder now in advanced position, all right, because the position at the left is used now, right? So port 1 flow to port 2, and then port 2 connected to our cylinder and move the cylinder in the advanced position, right? If we release, it will go directly to the initial position, which is retracted, okay, retracted position, okay. Okay, can you see? Right, push and then release will go back because of the spring effect, right? The spring will pull this one towards the right hand side, so this one will be selected again, okay, like that. You can see the value of velocity here, right? Okay. That's for the single acting cylinder. Okay, any question for this? So you need to really understand this one first so that we can move to other topics. All right, let's see our class again. Oh, not this one. So okay, we should switch on normally. Okay, no question. Okay, if no question, we go to the second one. If you see at the right hand side, all right, so if this one is the single acting, this one is the double acting. All right, double acting meaning that you have two ports, as I said. So because it has two ports, you need to choose the DCV or directional control valve here to have two ports at the top. All right, okay, so as for the previous one, we use 3 two-way valve, all right, where we only have one port at the top, all right, which is port 2, right? So this one cannot be used for the double acting. You can use in in practical, but of course you can only you can only make it advanced, right? And then you cannot make it go back to retracted position because you cannot control the other valve, the other port, sorry. All right, so to control the double acting cylinder, you need DCV with two ports at the top. So either you can choose 4-2, right, or 5-2. So if you see here, 4 or 5. So because these two, you have the two ports at the top, all right, so that you can connect to the cylinder, right? Double acting cylinder. Can we use this for double acting cylinder? Yes, because you have two ports at the top, which is port 2 and port 4. All right. Okay. All right. So this one, you can see that the from the power source, you connect to the port 1, which is the power ports, source ports, and then it has the connection to 2. All right. Port 2 now connect to the first port of the cylinder. All right. Right. So you have the flow of air here towards here, and then we will push this one, right, to the retracted position. All right. So the air here will go through to port 4, and then port 4 will go through to port 3 and go to atmosphere. So you can see here I use different symbol. So this one is the silencer. Right, silencer meaning that it will not make much noise. If you exhaust the air to the atmosphere, right? Otherwise, if you use this, it will be very loud. Okay, so this one is the silencer to make it silence. All right. Okay, that's the the initial position. If you push the push button, you have the flow from port 1 to port 4. Right, so you have the air coming from port 4 to our cylinder, and then we'll push this cylinder. All right, and then the air at the right hand side go through this port, and go to our port 2 here, and port 2 will be connected to port 3, and then port 3 will go to the atmosphere. Okay, so now it is in advanced position. Okay, let's simulate that. Okay, retracted, advance, retract, advance. Okay, the same principle with our previous ones. Okay, for the switch. Okay, if we push this, okay, it will advance. If we release, the spring will take effect and return the directional control valve to its initial position. Okay, and then go to the retracted position again. Right, advance, retract. Okay, advance, retract. Okay, that's two very basic circuit of pneumatics. Okay, so this one you want to control the single acting cylinder. The second one you want to control the double acting cylinder. Okay, so so you need to make sure you know the difference between these two. Okay, which port to use, which valve to use. Okay, and why, how it works. Okay, how it works. So this one you can control using one port, this one you control using two ports, right? Okay, do you have any question for this?
So I have question.
Okay, please.
Sir,
Who is asking?
I'm Mustaqim.
Mus. Okay, please.
Okay, sir. These two DCV operating much like same, right? Because it's when we push the manually push the button, then it will go from retracted to advanced, right?
Yep.
Then why exist these two DCV? Why not just one?
Okay, all right. So that's a very good question. So you can see that the function is the same, right? Meaning that in the initial position, the right hand side will be used. So if you manually push this push button, the second position will be used, right? The same. All right. The only difference is that number of ports. All right. So you can see that at the left hand side you have 3 ports, right? 1, 2, 3. Okay. As for the right hand side, you have 4 ports. Okay, 4 ports. 1, 2, 3, 4. All right. Why the difference? Because this one we have only one ports at the top, which is port 2. All right. So this one is used to control the single acting, because single acting have only one port. Right. So this one will connect directly to the top part of the DCV, right, which is port 2. Right. As for the double acting cylinder, you have 2 ports here. So you need DCV with 2 ports at the top. All right. So either you choose DCV with 4 ports, right? So that you have port 2 and port 4 at the top, so that you can connect right directly to the ports of the cylinder. Or you can choose also the 5-2 way. Okay, so let's say this one. Okay, stop first. Okay, maybe you want to instead of this you want to choose this, can also, because it has also have 2 ports at the top. Right, let's say you want to delete this, you want to replace with this. Okay, you can always do that. Okay, so now you connect this one to this. Okay, this one to this. Right, source, where do we want to connect this? 5, 1 or 3?
I think at 1.
1. Okay, so power source always connect to port number 1. All right, because it's the source port. Okay, how about the 5 and 3? So this one is the exhaust ports. Okay, so you can add this terminator. So maybe you put this, okay, to exhaust to atmosphere, this one, or you can choose the oops. So we choose number 1. Okay. Okay, now here. Okay. All right. So power source connected to port number 1. Port 3 and 5 go to atmosphere, exhaust, exhaust ports. All right. So, as for your question, the answer is that the number of ports different because it want to control different type of cylinder. So single acting cylinder will be controlled by the valve that has only 1 port at the top. The double acting cylinder, because it has 2 ports, so we need the DCV or control valve with 2 ports at the top. So either you choose 4 two-way valve or 5 two-way valve, right, to control. Okay. Did I answer your question?
Yes, sir.
Okay. So you can add spring. This one you can, maybe foot pedal, right? So in industry, sometimes the operator, because you have lots of buttons and you only have 2 hands, so maybe you use the foot pedal to control the switch. Okay. Right. Any more questions?
Sir,
Yep.
so where is the electrical part?
Okay. So where's the electrical part? There is no electrical parts. Okay. So the only electrical part is to power on the compressor. That's all. Okay. So here you can see the pressure source, right? This pressure source comes from the compressor. Right? The compressor, take the air from atmosphere, compress the air, and go through the filters, the dryers, and then we'll go to our system here, go to our pipe here, and then all after that you have no electrical elements. All are powered by compressed air, all powered by pneumatics, right? So there's no electrical element in this thing. Okay, any more questions? Any other questions?
Sir,
Yep.
can we make the shaft to move at mid position, not retracted and advance only, but move to the mid position?
Or you mean you want to make the cylinder at the mid?
Yes, yes. Can we make that?
Yeah, sure. But
How can?
yeah. So this one you need to use other intermediate DCV. So we'll go after this, maybe in the next class. Okay. So this one, all right. So this one we call it direct control of the cylinder. All right, direct control pneumatics. If you go to the slide, okay, I skip first this one. Okay, sorry, double acting, single acting. Oh, not here. So in the next one here, this one is called direct control. Okay, direct control. Yeah, direct control of a pneumatic cylinder. All right, direct control meaning that from the switch, okay, you directly control the power elements. All right, from switch, power elements. As for the indirect control, you have the intermediate DCV here. All right, we'll see maybe in the next session, indirect control. Okay. All right. So this switch thing purely mechanical. All right. So it has not. It can be other type of switches too. Not only mechanical. So if you go to the software here, properties. All right. So left actuation here, you can either make it spring return. All right. All right, or you can give it manually. All right, the push button and so on. Mechanically, same, I think similar to manual. All right, so you have this roller lever. Okay, or you can also make it electrically. All right, so this one, what is this? Can someone tell me what symbol is this? Someone? Who is asking the question? Muhammad Azhar? Are you with me? Can you tell me what symbol is this? Muhammad Azhar, you are not here? Close, normally close. Okay, so this one is the solenoid. All right, so this one will go more detail in our later session, inshallah. So where we connect from pneumatics to our PLC. All right, so instead of purely controlling our pneumatics using pneumatic system, we can also control the pneumatics using PLC. Okay, so you can also change this to, for example, solenoid. Okay, right? You can use solenoid. Okay, you can also control with both. All right, so either solenoid or the push button. Okay, so if you simulate this, all right, same. Okay, any other question? If no question, I will ask. Okay. So where can we download this software? Oh, so the software is not free, eh? So, but of course you can find the crack lah kan. But I, as for the for this class, I will not recommend the cracked version. But if you want to find by yourself, it's up to you. Okay. All right. So, oh, Muhammad Izzat already told you, crack. Yeah, you can find. I think you are more expert than me to find the crack. Okay. Yeah, use torrent or something, you know. Any other question? Okay, if no question, I ask you, what if we don't want to use 4 two-way or 5 two-way, right? Instead, we want to use what? 2 two-way. Okay. What will happen? Can anyone tell me? So let's
Only
put
have one position. Even though it's back.
only one position. What do you mean?
We cannot return.
Cannot retract. So this 2 we want to connect here, or you want to connect here? Which one? To the left or to the right? Port number 2.
Left.
Left,
To the
left.
left. Okay, let's try to the left. All right. Source to port number 1. Okay. So let's simulate this. Open connection. So in our simulator, it will say that this one is not possible. It will create error. But in real application, it can always be done. So yeah, you can test in your lab as well, lab 2. All right. So this one, if you push this, let's put the spring. Okay, if you push this position will be used. So now you have flow from 1 to 2. 1 to 2, this one will advance. All right, advance, but it will stay there. Okay, it will stay there. So even if you release the push button, so this position will be used, right? But you don't have any flow to this spot at the right. Okay, so you cannot retract the cylinder anymore. Okay, so it will be in the advanced position forever. Okay, unless you have the connect this to other control valve. Okay. All right. So any more question? Cannot return. I think cancel. It is possible if we start power source at 5 and not 1. Okay. So if you see the 5 2 way off. Okay, here. Right. So this is the 5 two-way valve. Right. So if you want, so this is can we say pesto, for example? This one is okay. So 5. Okay. Okay, this one, okay. Can we, instead of number, if it is 5 two-way valve, instead of 1, we want to connect the power source. Okay, power source to 5. Okay, the answer is cannot. Okay, so because this one is designed in such a way that power source can only be through port number 1, because port number 1 is the source port. Okay, so this is the the port where you put your piping. Okay, so source always go to port number 1. So even if you see in the drawing here, if you put it in port number 5, it doesn't make sense, right? So because the arrow is towards the power source. Okay, so power source always go to port number 1, okay, and port number 3 and 5 for the exhaust. Okay, that's very important, very important. So source to 1, 3, 5 exhaust, 2, 4 for the controlling of cylinder. Okay, that's the answer. Okay, I think if you don't have any more answer, maybe we go through the slide first. Okay, so this one I think you go through by yourself. You see the symbols, right? So for example, this one is pump. This is not important for the learning outcome of this class, but of course you can read by yourself just for your side information or knowledge. Okay, we have different type of pump. This one is filters. All right. So in real application, this one of course will you will get this in a bundle if you buy the the power source of the pneumatics. Okay. So let's say you are working as the design engineer. So I was a design engineer before. So this one will come as a bundle. So the power source, the compressors, the filters will come together. So this one doesn't matter. The most important thing is the design of this circuit. Okay. All right, filters, air compressors. Okay, so you can see different type of compressors. So this one maybe you already find this in thermofluids. Thermofluids is 4 credit hours. So if you fumble in that one, you are done. Okay, all right. Compressors. Okay, compressors. Receivers, air treatment. Okay, oh, this one already. Okay, this one. Number of ports. Okay, this why the numbers? This one following the standard of ISO. Okay, like this one, one. So you can call it 1 or P. So this one normally in standard in any drawing we use these numbers. This one you can find in books, but for the real drawing, right, the real engineering drawing, you can see use the ISO standard. All right, port number 1 for the pressure ports or source port, 2, 4 working lines, 3, 5 exhaust ports. Okay, this following the ISO standards. All right, the numbers you have to make sure you put it right. Okay, very important. So, and then you also have the pilot lines. Okay, 10, meaning that applied signal inhibits flow from port 1 to port 2, right? Where is 10? Here. So applied signal inhibits flow. Inhibits meaning that it will not given the it will not allow the flow from port 1 to port 2. So for example, this port 10, if this one is activated, right? If port 10 is activated, so this position will be selected, right? If port 12 is activated, this one will be chosen. So this one I will talk more in our next class, where we will go into indirect control. Okay, so just want to talk about the ISO standard of the port numbers. Okay, 10 and then 12 applied signal connects port 1 to port 2, right? So this one sometimes you if you want to easily remember, you don't call it 12, you call it 1 2, right? port 1, 2, meaning that you have the flow from port 1 to port 2. All right. So this one, port 1, 0, port 1, 2, 0, because it is blocked. Okay. All right. So port 14 or port 1, 4, applied signal connects port 1 to port 4. All right. So meaning that port 1, 4, meaning that you have the flow from 1 to 4, right? From port 1 to port 4. Okay. So you have 10, 12, 14. And then you have also this 81 and 91. So this one is auxiliary pilot air. All right. So this one is rarely used. Okay. This one is important. 10, 12, 14. Okay. This. Okay. Port designation. Okay. This one I'll touch more in our next class. So the energy supply unit. Okay. So remind me of this. So we'll go through again this one. How to give the designation to the ports. Okay. One A, one A, one V1, one S1. How to give this one. Okay. And then you have lots of types of actuation. Okay. Push button, lever operated, foot pedal, and so on. Okay. You can put it as mechanical as well, roller lever, spring, and so on. Okay. Okay. Type of actuation. This one is meaning that you have the source from the pneumatics, right? So this one is the piloted pneumatics. Okay. And this one is solenoid. Okay. Solenoid, double solenoid. And you have the combination of those as well. Okay. And then this one you can go through first, but we'll go through more deeply in our next sessions. Okay, so this one is non-return valve. You know, this non-return valve, this one is like a ball, right? Like a ball. So meaning that if you have the signal from the right, okay, so this one will close the flow from right to left, right? So you cannot have the flow from right to left, right? So you only have the flow from left to right. Okay, so you have the flow from left to right. This ball will release and will give the way of signal from left to right. Okay, non-return valve, spring loaded. You have different type of symbols. All right, shuttle valve, all valve. So we'll go this end valve, quick exhaust. This one we'll go through in the next class, inshallah. Okay. Okay, this one I have shown you this. Okay. This one is like repeated. Okay. This one you can go through by yourself. Okay. Double active cylinder with cushioning. All right, cushioning meaning that it will go, will not damage this cylinder. Right, just different type of cylinder, but the working element is the same. Right, the working methodology is the same. Right, different type of cylinder. Okay. So 3 two-way valve. So this one is the cross sectional of the 3 two-way valve. This one is the pneumatic symbols. Okay. Okay. When you see this symbol, what does it mean at the right? Can someone tell me?
Is it like cam follower?
Nope. So at the right you have this. At the left you have this, and then at the right you have some something at the switch here. What does it mean? What's the difference between those? Can someone tell me? All right. So this one means that this one is the initial position, at the left. So at the right, it is the switch is being applied, right? So meaning that now the position, the second position is selected at the left, right? Okay. Very easy, yeah. 3-2-way valve is what I've already go through. Okay. This one you can go by yourself. Okay. So I'm just the symbols. So we'll go more detail in the next class, inshallah. Okay. That's all. I think that's all for today. All right. Just get a very good understanding of this. Okay. How the working principle of this, how the air flows, how the advance and retraction position is selected. Okay. Any more questions before we postpone our class?
Sir, I have question.
Yep.
Normally we use how much pressure for the compressed air?
Oh, how much pressure? So that one depends on your application. So for heavy, anyone from robot team here? Robot team and Robocon. I think they have already used pneumatics before. Anyone from robot team? No one. Okay. Because I think in last year robot, they use the they put the compressed air in the what you call it, in the
Bottle, right?
yeah,
Plastic bottle.
yeah, the Coke bottle, I think, Coke or Pepsi
Right.
bottle.
Yes, something like that.
Yeah, so I think that one is 5 bar or something. 5 bar. Yeah, that one always depend on your application, right? So even in this software, you can put the pressure as well. All right. We have where can I put this? Can't remember. Okay, you can put the pressure as well here. You can simulate. Okay, but that one it's not important for the LOs, but it's very, very good to know how many bars you need for your application. All right. So any more questions? All right, so today we'll have a quiz at 5. Okay, so 5 to 9. 5 to 9, right? Today?
Yes, sir.
5 to 9. Okay, very simple one. Okay, very simple one. So I'll open the session in the Talim. So how we want to submit is that I think I'll tell you afterwards. I think maybe you need to snap and convert to PDF, for example, and then upload to the iTalim. All right. Okay.
Okay, sir.
Okay. All right. Okay. I think that's all for today. If you have any question, you can ask me directly to my WhatsApp at any time. Okay. All right. So with that, we'll see you in the next class on Wednesday, inshallah. Okay. All right. Thank you everyone for this session. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you.